Hello, this is the part 2 of the mathematics exam of the year 2013. Let's go. The second part says, consider the function capital F is equal to the integer from a to x is equal to this expression here, but a is the constant and isn't 0, okay? Find a. First, what is capital F? Capital F is this expression here. So, capital F is x cubed minus 2x squared plus x minus the constant a. And the derivative of capital F is f. So, the derivative of capital F is f. F on x, okay? This expression is the derivative here, so the derivative is 3x squared minus 2 times 2 is 4x plus 1, and the derivative of a is 0. Now, what is the function on t? Okay, it's the same of x, but instead of x is t. Okay, it's easy. And t is 3 t squared means 4t plus 1. And the derivative of ft, the derivative of ft is t3 minus 2t squared plus t. Now, what is the derivative back from a to x? The derivative from a to x, is that very okay, x, that is x cubed minus 2x squared plus s plus x minus a cubed minus 2a squared plus a. Okay, and now look at that. This derivative here is the same of that. Look at that. x cubed minus 2x squared plus x and minus a, but what is that? So this, all of this is a, okay? Look at that. Minus a cubed minus 2a squared plus a, that is a. Then a is equal to a cubed minus 2a squared plus a. And that is a equation to find a. So that is 0, that's a cubed minus 2a squared plus nothing, because that is minus a, okay? And 0 is equal to a cubed minus 2a squared. And now for common factor, that is a squared here, a means 2, because a squared times a is a cubed, and minus 2 times squared is minus 2a squared. That is the equation here. And what is a can be so sorry, a squared can be 0 or a minus 2 can be 0. That is the same. That is the same to say a can be 0 or a can be 2, because if a is 2, 2 minus 2 is 0, and if a is 0, 0 times 0 is 0. But remember, a can be 0, okay? A can be 0, so that is fake, that is false. So a is 2, okay? A is 2, because that is false, that is fake, okay? So the correct answer is a is equal to 2, okay? Let's do second question. The second question says, find the range of x where capital F is greater than 0. Let's go. What is capital F? Capital F is x cubed minus 2x squared plus x minus 8. But we know that x is equal to 2 minus 2 is greater than 0. Okay. Now we going to use the reference method. So 1 minus 2, 1 minus 2. Okay. And the multiplies of the constant and the first term is 1 minus 1, 2, and minus 2. We're going to use the first one. Okay, 1 goes down. And 1 times 1 is 1. 1 minus 2 is minus 1. 1 times 1 minus 1 times minus 1 is minus 1. Minus 1 plus 1 is 0. 0 times 1 is 0. And 0 minus 2 is minus 2. And that isn't. Okay, let's try with the 2. Okay, a 1 minus 2, 1 minus 2. Okay, 1 minus 2, 1 minus 2, and 2. Okay, and the number 1 goes down. 2 times 1 is 2. 2 minus 2 is 0. 0 times 2 is 0. And 0 plus 1 is 1. 1 plus 2 is 2. And 2 minus 2 is 0. Okay, and that is, this expression can be written like x minus 2. Okay, and 1 0 1, 1 0 1, and that is 1 times x squared 0 plus x, and the constant is 1, and x times 0 is 0. Okay, and that is the same of x squared plus 1 greater than 0, because these two polynomial multiplying is the same of this big polynomial here, greater than 0. Okay, Okay. Um, when this expression is greater than zero, um, let's go to see. Uh, this is the first expression, x means 2, and this is the second, x squared plus 1, that is negative infinity minus 1, 1, and 2, and positive, positive infinity. Okay, um, when this expression is between negative infinity and minus 1 is negative. When it's between minus 1 and 1 is negative. When it's between 1 and 2 is negative, but here is positive. Okay. No, because that is the square. The I square is always positive. Okay, that's always positive. And minus negative times positive is negative, negative times positive, negative, negative, and positive times positive is positive. So that is greater than 0. So that is positive, because greater than 0 is the same to saying that is positive. Okay, and that is the range of x. X is greater than 2. Okay, x greater than 2. So find the range of x where the capital F is greater than 0 is easy. Is x is greater than 2. Okay. The question number 3 says, find the area of the region surrounded by the x-axis and the graph of f on x. And that is easy. Yes, that is easy because it's only one derivative, but it's very long. Let's go to do. Find the area surrounded by the x-axis of the graph f. What is the graph f? F is 3x squared minus 4x plus 1. When this question here is on the x-axis, when this expression is equal to 0, okay, this expression is equal to 0. Let's go to factorize. Minus 3 1, yes, but that is divided by 3 and is x minus 1 times 3x minus 1. Okay, and the first x is 1, x sub 1 is equal to 1, and x sub 0 is equal to 1 divided by 3. And okay, this parabola here is positive, and this coordinate is 1, and this coordinate is 1 divided by 3, and that is the area here, but this area is negative. But with an absolute value, can be positive. Yes. So the derivative of from 1 to 1/2, sorry, 1 divided by 3 to 1, because that is 1 divided by 3, and that is 1. Sorry, because 1 is greater than 1 divided by 3. Um, of this expression here. This expression here, yes, is the area, but a negative area. Okay, the integer of this expression is x cubed minus 2x squared plus x from 1 divided by 3 to 1. 1, that is 1 cube. 1 cube is 1 minus 2, 1. 1 square is 1 plus 1 minus 1 divided by 3 square, sorry, cube is 1 divided by 27. Yes, it's very big. Minus 2 times x squared, and x is 1 divided by 3, and 1 divided by 3 squared is 1 divided by 9. 1 divided by 9 plus 1 divided by 3. Okay, minus 2 plus 1 plus 1. 1 plus 1 is 2, divided, and minus 2 is 0. 0. Minus 1 minus 2 times 3, because that is divided by 27 plus 9. Okay, 2 times 3 is 6, and 9 minus 6 is 3 plus 1 is 4. That is 4 divided by 27 minus 4 divided by 27. 7. That is the area, but that is negative, and one area isn't negative. And so, with the absolute value is positive, okay? 4 divided by 27. And find the area of the region surrounded by the x-axis on the graph f on x is, my parabola is 4 divided by 27. That is all of the question of the part 2. Let's go to the part 3 and final part of this mathematics exam of the year 2013.